Welcome to the YouTube channel. We are explaining. The Earth is round. It may not be a perfect circle, but it is round. We have known this for quite some time. The Greeks discovered this more than 2,000 years ago. They did not have spacecraft that could take pictures, and they did not have ships that could orbit the Earth, but they could use trigonometry. They looked at the shadow of certain objects, in different places, and that is how they deduced the shape of the Earth. They even calculated its circumference, and were very close to the correct answer. But we say that the Earth has a shape only because we can grasp it. We can see that it is round. If we had giant hands, we could hold it, and feel that it is round. But what is the shape of something that we have difficulty grasping? What is the shape of the universe? The very question is already supposed to confuse us. After all, what is the universe? It is everything that exists. All matter and energy are in it. All space is in it. Both space and time are in it. And every event that happens in the universe. Asking what the shape of the universe is like asking what the shape of everything is. And how can you even ask such a thing? After all, the only way I can perceive a shape is by its boundaries. For example, if I draw a square, the reason I can perceive that it is a square is because I see its boundaries. Everything inside the lines is the square, and everything outside them is not the square. So if the universe has a shape, what about everything outside this shape? Isn't it part of the universe? How can that be? After all, the universe is everything, but on the other hand, the universe must have a shape. After all, the universe contains physical things, and energy, and the laws of mathematics and physics. It is a place, probably real, where things happen, and every physical thing that exists must have a shape, right? Well, fortunately, we do have clues that allow us to talk about shape. The evidence indicates that the entire universe was once compressed, about 14 billion years ago, into a single point, infinitely dense, where the Big Bang occurred. This point stretched and expanded, and became, over time, the universe that we know today. But before we talk about the shape of the universe, we need to talk about the structure of the universe. We need to talk about the cosmological principle. This name may be scary, but don't worry, it's not that complicated. The principle says something like this: when we look at relatively short distances, for example, from our galaxy, the Milky Way, to the galaxy closest to us, Andromeda, every point in the universe seems different and unique to us. But if we look at the structure of the universe more broadly, and explore its overall picture, we will discover that the universe is very uniform and that there is no point in the universe that is essentially different from any other point in the universe. It's like if we take a gas and look at it from a distance, it will seem uniform to us. But if we look at it at the molecular level, then every molecule and molecule will look special to us. There is no point in the universe that is truly special. And because of this, any point in the universe can serve as a reference center, and therefore the universe does not really have a center. All points in the universe are on a symmetrical system, located around a center that is spatially unreachable today but that once was, the point of the Big Bang. We are moving further and further away from this center in terms of time. But also on a spatial level, the universe continues to stretch and grow at a rate that is accelerating over time, and it does not seem to be slowing down. The truth is that we are not sure why the universe is growing. After all, there are objects that are supposed to exert a gravitational force on each other and slow down this expansion. We call this incomprehensible force that causes the universe to continue expanding dark energy anyway. If we try to bring to our limited human imagination the shape of such a universe, we might say that the universe is a type of object that expands in a void. This void is probably infinite, and therefore, if the universe continues to grow and stretch, as it is doing now, its shape is infinite, in all directions by the way. If this is really the shape of the universe, eventually it will be so big, and everything will be so far away from everything else, that there will not be enough energy in the universe. If the amount of energy is finite and the size of the universe is infinite, eventually there will not be enough energy for anything. Without energy, nothing can happen anymore. Then we will have an infinite universe, and die. On the other hand, it is possible that this incomprehensible expansion of the universe will stop at some point. Maybe the galaxies will exert a gravitational force on each other that will be able to overcome the dark energy, and stop the expansion and then maybe even cause contraction. Maybe, over time, as the universe is growing now, it will stop and then contract in the future, and it will contract and contract and contract, until it returns to being a single point with infinite density just as it was before the Big Bang. If this is the shape of the universe, then it is indeed finite. Because it will end someday, but if this is the final shape of the universe, and if it really will return to a single point in the future, so maybe it will grow again some other day? Maybe this is a process that has already happened infinitely many times. Maybe the universe always starts with the Big Bang, expands, contracts, and then starts again with another Big Bang. And maybe it always happens exactly the same way? Maybe our universe has existed over and over again since time immemorial, and we have existed with it many times in the past? How many times in the past have we already died? Maybe infinity. There is another option, which seems a little less likely. What if one day the universe stops expanding, but gravity still doesn't have enough power to shrink it? In other words, what if gravity and dark energy reach a perfect equilibrium? The universe will take a final shape, and remain static. It is worth noting that this is a very unlikely situation, which would be very unstable if it really happened. It's like trying to balance the entire universe on the tip of a pencil, but it's a possibility that exists in theory. Maybe if the universe were static and stopped expanding or contracting, we could discover new things about it. For example, maybe we'd find that if we kept moving further and further in a certain direction, we'd eventually end up back at the same place. Maybe the universe is a very large space spread out in a circular fashion. But in general, we try to grasp the shape of the universe in our human terms, and that's not really possible. We're animals that perceive the world and its shapes in a three-dimensional way. Everything has length, width, and depth, so when we imagine the universe, we try to imagine a three-dimensional shape that would characterize it. But how many does the universe have dimensions? We don't know the exact number. But we do know that there are at least 4 dimensions: depth, width, height, and time. Time is another dimension of the universe, but we can't perceive time as something that has a shape. If you try for a moment to imagine something with 4 dimensions, you'll find that it's impossible. We have no way of grasping it, and therefore, even if one day we manage to understand exactly how many dimensions the universe has, and exactly what its shape is, we still won't be able to imagine it accurately. It's simply a mechanism that we lack in our minds, but the truth is that if we cheat a little, we can imagine time as an additional dimension. All we have to do is imagine for a moment that we live in a 2-dimensional world, not a 3-dimensional one. We only have width and length, no depth. So we can draw the whole of existence as a 2-dimensional drawing. Now imagine that there is a 3rd dimension, and this 3rd dimension is time. As time progresses, we will discover that our reality will inflate like a balloon, and every point in space and time will have width, length, and time. How do we know that time is just another dimension and not something completely separate? More on that another time, perhaps. If you are enjoyed this video, please subscribe to We Are Explaining YouTube channel. Drop a like please if you want to support this video and bring more content like this.